Hello, I'm Firuza, and you are on the channel Bold Science with Firuza. Today we're gonna talk about what makes real physics alive, honest, and beautiful. We'll look at the foundation of science, at what distinguishes a hypothesis that changes the world from an idea that remains nothing more than words. What is a scientific hypothesis? Have you ever thought about what makes a hypothesis scientific? Most people would say, well, it's just an assumption. Technically, yes. But in real physics, the kind that is tested by the experiments and changes the world, things are far stricter. A scientific hypothesis is not a pretty thought. It's a tool that must withstand the pressure of reality. And if it doesn't, it gets thrown away without sentimentality. Any hypothesis must satisfy three strict criteria. Without them, it has no right to be called scientific at all. Let's examine the first criterion. Criterion number 1, falsifiability. If an idea cannot be tested and cannot be disproven, it's not a hypothesis, it's poetry. A scientist who proposes a hypothesis must specify a test that could show the hypothesis to be false. Yes, exactly that. Don't be surprised. In other words, the experiment must give the scientist a chance to say, yes, I was wrong. If no such experiment exists, then the author simply doesn't understand what they are claiming. An example. When Michelson and Morley tested the existence of the luminiferous ether, they reasoned as follows. If a world ether exists through which the Earth is moving, then light beams traveling along the direction of Earth's motion should encounter resistance from the ether and take slightly longer to travel than beams moving perpendicular to that motion. They formulated two clear and measurable predictions in advance. If the ether exists, the interferometer will show a shift in the interference fringes. If the ether doesn't exist, there will be no shift. The instrument will show a null result. What is a null result? It's a simple and precise conclusion. The expected effect is completely absent. The interferometer showed no fringe shift at all, neither large nor even barely noticeable. And if there is no shift, then the phenomenon that was supposed to cause it wasn't confirmed. The experiment produced exactly a null result, and Michelson and Morley acknowledged this openly, even though many physicists of that era were expecting the opposite. This is what real science looks like, an honest test and a willingness to receive the answer no. A hypothesis that doesn't risk being disproven is no longer science, it's dogma. And this is precisely what distinguishes a real science from dogma. A hypothesis must take a risk. If it cannot be falsified, it's not science. But that was only the first criterion. Things get even more interesting from here. In the next video, we'll examine the second criterion, and believe me, many popular theories that sound convincing fall apart at exactly this stage. Thank you for being with me on the channel Bold Science with Firuza. If you value honest, rigorous physics, stay with me. Like, subscribe. What comes next will be deeper, sharper, and far more exciting.